Oh, right. If you're an AI engineer, you know fine-tuning is one of the most powerful tools in our entire arsenal. But using it the right way, that requires a really solid mental model. So this is your strategic guide to supervised fine-tuning, SFT for short. We're going to cut through all the noise and just focus on what actually works.
I love this quote because it just hits the nail on the head. We are not sending our model to kindergarten to learn its ABCs. Not at all. We're taking this brilliant generalist model that already knows so much, and we're sending it to grad school to become a specialist. SFT is all about honing a very specific skill.
And that brings us to the really crucial difference between this and pre-training. So pre-training, that's the unsupervised phase where the model is just, gobbling up the entire internet, building this huge general knowledge base. SFT, on the other hand, is a supervised process. We use a small, super high-quality, labeled dataset of examples to teach it one specific task. It's generalization versus specialization.
Now, when you decide to specialize a model, you've basically got two ways to go. There's full fine-tuning, where you update every single parameter. It's super powerful, but honestly, it's a resource beast. You need some serious hardware, like H100s. But the modern way, the way most of us do it now, is with parameter-efficient fine-tuning, or PEFT. With PEFT, we freeze most of the model and just train a tiny little fraction of new parameters, usually using a technique called LoRA.
And the impact of LoRA, that's low-rank adaptation, it's just staggering. It can slash the number of trainable parameters by a factor of 10,000, sometimes even more. This isn't just a small improvement, it's a total paradigm shift. It's what takes fine-tuning from these massive data centers and puts it right onto our local machines. It's a game changer.
So that brings us to our first big strategic choice. Do you go the API route or the open-weight route? You can think of it as choosing between a managed black box for speed and convenience versus a hands-on white box approach where you get total control.
Okay, so the API path, like what OpenAI offers, is all about getting things done fast. It's incredibly simple. You just format your data into a JSON lines file, make a couple of API calls to upload it and kick off the job, and boom, you get back a new model ID. This completely abstracts away all the messy MLOps stuff so you can focus on what really matters, the quality of your data and your app's logic.
The open-weight workflow, on the other hand, is where you get total control. You're leveraging that incredible Hugging Face ecosystem, libraries like Transformers, PEFT, and TRL, and you manage the entire pipeline yourself. You load the model, you configure the LoRa adapters, run the training loop, and then deploy it on your own infrastructure. Yep, it takes more expertise, but the transparency and the ability to customize are just unmatched.
But here's the thing. It doesn't matter which of those paths you choose, API or open-weight, because we've now arrived at the single most critical part of this entire game. It's not the model you pick, it's not the hyperparameters you tune, it's your data. In SFT, your dataset isn't just an input, it is the blueprint for your specialized model.
This quote from the famous Lima paper is pretty much the golden rule here. What they showed was that a model fine-tuned on just 1,000 really high-quality examples could actually outperform models that were trained on way bigger, much noisier datasets. The takeaway is clear. The quality of your data will always beat quantity. And here's the part that's truly remarkable, the part that makes this so accessible. You don't need tens of thousands of examples to get started. In practice, you can see really meaningful, noticeable improvements with as few as 50 to 100 meticulously crafted, high-quality examples. The real work here isn't computation, it's curation.
So what does a high-quality dataset actually look like? Well, it really boils down to four things. It's got to be relevant, laser-focused on what you're doing in production. It needs to be consistent in its formatting. It has to be diverse enough to cover your edge cases. And, this one's key, it needs instructional fidelity. That just means the prompts you train on should look exactly like the prompts you're going to use in the real world.
Okay, so we've got our model and we have our data. Let's talk about the state-of-the-art process for alignment. Because while SFT is the foundation, the industry has pretty much moved on from the old, complex RLHF to something much more elegant. You can just see the evolution here, right? RLHF was powerful, but let's be honest, it was a beast, notoriously complex, unstable, with 3 different training stages. Then came direct preference optimization, or DPO. It achieves the exact same goal, but with a simple, stable, single-stage process using chosen versus rejected response pairs. It is no surprise at all that this has become the new industry standard. So this brings us to the modern playbook. The best practice today is a 2-stage process. First, you do SFT. but only on your best gold standard examples. This gets the model into the right ballpark. It teaches it the correct format, the right style. Then you take that SFT model as your new base and you refine it with DPO to align it with more subtle human preferences.
We have covered a ton of ground on the what and the how, but before we wrap this up, we have to talk about the single biggest, most dangerous misconception about SFT. This is a mistake that can actually ruin your model's performance and reliability.
Let me just ask this question straight up. You have data that came out after your model's knowledge cutoff. Your first instinct might be to just fine-tune the model on all this new information. So is that the right move?
The answer is a hard no. Absolutely not. SFT is a terrible, terrible tool for injecting new knowledge. All the research shows it's not just ineffective, it can actually make things worse. It degrades the model's factual accuracy and can dramatically increase hallucinations. Why? Because the model just learns to mimic the style of a knowledgeable answer, and it will just make up facts to fit the pattern you've shown it.
And this right here, this is the core strategic takeaway for this whole thing. The rule is incredibly simple. You use SFT to control how the model responds, its behavior. It's perfect for shaping style, tone, or making sure it always gives you valid JSON. But to inform what the model responds with, you need Retrieval Augmented Generation, or RAG. RAG gives the model the facts as context right when it needs them. So just remember the mantra, SFT for behavior, RAG for knowledge.
And there you have it. That's the mental model. It's a full framework for turning these generalist models into true specialized experts. You control the style with SFT, you align preferences with DPO, and you provide knowledge with RAG. You now have the complete modern playbook. So the only question left is, what expert are you going to build next?